Don't miss out on the new industrial components that will revolutionize the way you play. In this video, I'm going to show you the new components, as we go step by step through a real world scenario to build an automatic gunpowder crafter and resource sorter. I'll also go over a few tips and tricks to help you fully take advantage of the new system. Hey guys, Jfarr here, and let's get started. The pipe tool is an essential industrial component, and like the wire tool or hose, is used to establish connections between different industrial components. The pipe tool has several properties, such as being able to change its colour by holding R, lack of durability, and a maximum range of 30 meters, along with a max of 16 pipe placements. The pipes cannot go through walls or solid building structures. Instead, you'll need to pass them through doorways, which allow you to place doors while there are pipes below. The pipe tool is a default blueprint with a cost of 2 high quality metal. Almost all industrial components require power, therefore let's make sure we have that set up before proceeding. If you already have power set up and know what you're doing, feel free to skip over to the next chapter. I also have a dedicated electricity guide if you'd like to learn more about the system. For convenience, we'll just get ourselves a couple of solar panels and a medium battery. However, using a cheaper power system is an option, but it leaves less room for future growth. Find a secure location to place your battery. Now locate a place to put your solar panels that is unobstructed and faces towards the sun. Use a root combiner to link the 2 solar panels and connect this to your battery's input. I would suggest adding a few electrical branches so we can power multiple devices. The storage adapter is a crucial component, used as an input and output port for containers, requiring no power. If you ever want to get an item from a container, through a pipe to another container, you will need storage adapters on these containers to do so. The storage adapter can be crafted at a level 1 workbench with a tech tree cost of 190 scrap. Pull out the adapter and you will see it will start to snap on the side of containers. Currently, it can be attached to the 12 containers seen here. Once you have an adapter placed down, pull out your pipe tool to see the connection nodes. You'll see an input and output node. You can connect the adapter's output to another adapter's input. However, nothing will happen. That's where we'll need the industrial conveyor. Finally, we can get things moving with the industrial conveyor. Everything so far has been static and non-functional. However, we can finally tie it all together with the conveyor, now requiring 1 power. I like to think of it as a vacuum. If we have a pipe connected between 2 containers, the items aren't going to magically float there, and will need a way to be sucked out of the container and into the target. 32 is the max number of items the conveyor can transfer per stack. If you have a stack of 64 items, it will send through the first 32, and you'll have to wait for the next tick for it to transfer the next 32 items. If you have 2 stacks of 32 items, it will send both at once. Additionally, if you want more refined control, you can hold E on the conveyor to open more options. From here, we can filter the items we would like to transfer out. Along with setting a min and max value. Setting the min value to 500 would mean it would only transfer that item out until it drops down to 500, at which point it will stop. Setting the max value to 500 would mean it would only transfer that item out until the target chest reaches 500 of that specific item, at which point it will stop. With the wire tool in hand, you can access up to 6 nodes. The first being the default power input to run the item. However, we also get access to a pass-through node, making it convenient to power multiple other conveyors with a single wire source, as it will pass the power from the initial wire through the machines to other devices. Next, we have the turn on and off node, which when powered will do either of those actions. Finally, we have the filter pass and fail node. The filter pass node will send out power when there are items that can pass through the conveyor. The filter fail node will send out power if there aren't any items that can be passed through, or if the crate is empty. The conveyor can be crafted at a level 1 workbench with the tech tree cost of 210 scrap. Place your conveyor on the wall near the containers. Now connect the adapter's output node with the conveyor's input node, and the conveyor's output node with the target adapter's input node. We have now formed a network. Make sure to power the conveyor so we can now turn it on to start the item transfer. Just place some items within the chest and watch them be transported out. Next, let's look at the newest smelter, the electric furnace. As you may expect, this will act the exact same as a regular furnace but require 1 electrical power instead of wood, therefore producing no charcoal. When we compare the speed of cooking up 100 metal ore in all the furnaces, the electric furnace ends up being 40% faster when compared to the regular furnace, with the large furnace being overall 80% faster. It can be crafted at a level 2 workbench with a tech tree cost of 820 scrap. We'll place our electrical furnace between 2 crates. Our goal is simple: transfer the raw resources we quickly dumped into a chest into the furnace to be cooked up. The cooked resources will then be dumped into our target container to be later used in crafting. Place down a storage adapter on the side of the furnace. Then we'll need to link the 2 adapters together with the conveyor as the middleman. Don't forget to change the settings of the conveyor to only pass through the resources you intend on cooking. Then we'll need to connect the furnace's output to a final chest's input with another conveyor in between. Without a filter, the conveyor will only transfer the furnace's output slots, so don't worry about it taking out the raw resources. Finally, we'll need to power the electric furnace and conveyors. Grab your wire tool and connect the power source to the furnace, along with powering the conveyors with the pass-through node. Turn them on and watch your resources start to flow through the system. The industrial crafter can be integrated into our system. The crafter requires a workbench to be snapped onto, but to actually craft the items you'll need the item's blueprint, which can be obtained from placing that item into a research table along with some scrap. Place the blueprint and materials inside and make sure to power it to start producing your item. Remember, the blueprint you include must be within the tech tree for the workbench you placed it on. With the pipe tool out, you can access the input and output nodes for the raw materials coming in and for the crafted items going out. You can also use the blueprint in and out node to automatically transfer blueprints for the items you want to be crafted. With the wire tool out, you can access the primary power in node along with turn on, turn off and toggle nodes. As you might expect, if it receives power through the turn on or off node, it will do either of those actions. If it receives power through the toggle node while off, it will turn on and vice versa. Let's compare the manual crafting against the industrial crafter for some common items. We can see across the board manual crafting is faster. However, with the crafter it can be operated 24/7, so keep that in mind. It can be crafted at a level 2 workbench with a tech tree cost of 970 scrap. My goal is to use the resources out of the furnace to automatically start producing gunpowder. However, for this example, I'll swap out the electric furnace with a regular furnace, so we can automatically produce charcoal. Configure the conveyor to accept wood, so we can place it into the raw input chest to keep the furnace fueled. Place the crafter onto the level 1 workbench. Place a conveyor at the cooked resource chest. Connect it up and link the conveyor's output to the crafter's input. Configure the conveyor to only pass through a max of 40 sulfur and 60 charcoal, as that's double the amount it costs to craft one, so we'll have some spare. Power both the conveyor and crafter and we're almost ready to start crafting. The final thing we'll need is a blueprint. It might seem strange, but we need to get the gunpowder's blueprint from the research table. Place it inside with some scrap and research it. With the blueprint, place it in within the crafter and turn it on. Now resources will begin to flow from the cooked crate into the crafter, automatically cooking the gunpowder. The industrial splitter allows you to branch a single pipe into 3 new pipes and requires no power. This can be especially useful for filtering items within the same container to different places. Let's understand how the splitter splits our items between the nodes if we don't have any item filtering. The splitter will first prioritize sending items to the lowest number node that's connected. So if you have pipes connected to output 1 and output 2, the splitter will always send it out to output 1 if it can. As we previously discussed, the conveyor can only transfer 32 items per stack, so you may ask, how will it split the transfer between the crates? The number it splits the stack at is 32 divided by how many pipes are connected to the output nodes. So let's say we have an input crate of 10 stones with 3 outputs linked. It will send the 10 stones to the crate connected to the output 1 node. If we have an input crate of 20 stones, it will send 10 stones to the output 1 crate and the other 10 to the output 2 crate. If we have an input crate of 30 stones, it will send 10 stones to each of the 3 crates. If we only had a total of 2 crates connected, the stack split will now be at 16. Therefore, if we have 16 stones or less, it will always go to the lowest output node first. However, if we have a crate of 32 stones but between 2 stacks, it will send them all through the output 1 node, as it only sends to the next output the items in the stack that exceed 16. The splitter can be crafted at a level 1 workbench with a tech tree cost of 230 scrap. Now we have the furnace's output crate sending items to the crafter. What if we wanted to filter the other resources, such as our metal fragments, into a separate crate? We can use a splitter to branch off our pipes. Remove our original conveyor. We'll place 2 splitters down. Connect the chest's adapter to the input of the splitter. Now connect the second output of the first splitter to the input of the second splitter. Make sure to place a conveyor filtering that specific resource for each crate between the splitter and the adapter. Now we can use each one of the second splitter's outputs to filter our nodes. Configure the conveyors for only that resource and set a max value for the sulfur so it isn't all sucked away, as we'll still need the crafter to access some. Connect the first splitter to the crafter with the conveyor in between. This will now need to be the one filtering for sulfur and charcoal. Finally, make sure to share power with all the conveyors. Let's also now add a splitter at the first raw dump chest. We'll connect the first split node to the furnace to continue cooking the raw resources. Now place a conveyor at the target chest and filter for stones. Link this up with the dump chest. Finally, rearrange the pass-through power to the stone conveyor and relink the crafter conveyor. The combiner is the exact opposite of the splitter and will combine up to 3 pipes into a single pipe node. This can be useful for taking items from 3 containers and dumping them into a single location. This also allows us to save on using multiple conveyors since a single one can be used for transferring the items through all 3 input pipes. The combiner can be crafted at a level 1 workbench with a tech tree cost of 250 scrap. Now I would like the gunpowder, that is the output of my crafter, to get dumped into the cooked crate. Pick up our original conveyor and place a combiner near the input of our cooked crate's adapter. Connect the furnace's output and the crafter's output to the combiner. Place down the conveyor with no filter and connect them all together. We'll now be dumping our smelted resources and crafted items into a single crate. You now have a completely automated system where you can dump your resources, get it cooked, automatically craft gunpowder, and filter it all into corresponding crates. Never again will you have to worry about filling up your TC. Have a main dump chest that will take the stone, metal or wood if the TC is getting low. We can use the min-max settings to configure it, so if the TC gets lower than that specific value, it will get some more resources. Keep your large furnaces secure by putting in the lowest amount of raw resources to cook up and constantly taking out the cooked resources and dumping them within a secure crate. Make sure to set the conveyor to only input the raw materials and wood. Set the max value of around 8 to 12. We can now have a dump box where we quickly dump all of our resources in so we can run off while they'll be sucked back into the main base. You can also increase the speed if you split up the stacks. Let's say I have a single crate I can dump all my items in and they'll automatically be sorted into a resource, components, tools/weapons, and everything else chest. Well, this can be done. You'll need to link your dump chest to the everything else chest. This will typically be a safer inside crate, compared to the dump chest which may be outside or in an airlock. Now everything will be put in here and we'll need to filter out the items you want. Connect the everything else chest to the splitter. Connect the splitter's output to your filtered chest with the conveyor in between. Set the conveyor to filter for that specific resource. Once they are powered, you are now done. And that's it. Thanks guys for watching and I hope to see you in the next one.